Hey everybody, and welcome to the second of a series of videos on limits of transcendental functions. So a quick recap: the first video talks about what a transcendental function was going to be considered, and we specifically looked about the behaviors of exponential functions as x went towards positive or negative infinity. And the way that we did that is by looking at the graph given to us with a function of some kind. Well, now we're going to be kind of, can we generalize what we are seeing in those graphs? The value of the base is generally going to tell us whether we have a growth function or a decay function, meaning that is it going to increase over time or decrease over time. Now, generally we think of growth functions as functions that are going to be have a base value, something that is between, or something that's greater than 1. Well, in this case, I can have a growth function if the base is between 0 and 1 also, as long as there is a reflection of some kind, typically a vertical reflection. And with the decay functions are typically going to be something that is between 0 and 1 for the base, and they decrease over time, so this is why we think of them as decay. We might think of them as like radioactive decay, or the number of bacteria in a petri dish after some antibiotic has been administered or something like that. So here, but we also see that the decay functions could also have a base of greater than 1, as long as there is a reflection of some kind. So now you've seen how to graph functions, or how to kind of take general information about functions and graph them and identify their behaviors that way, and that's what we're going to be looking at here in these examples. Now I'm going to go ahead and do the first example for you, and I'm going to ask you guys to try and do the next 3 on your own. Now the first example here, you can kind of look and say, okay, well, the base value, that is that's a decay number. It's between 0 and 1, but I also have a vertical reflection. That's what the negative sign in front means. So based off of those information, those two things, I should be able to conclude that the function will approach negative infinity as x goes towards negative infinity. Now, graphically, why is that occurring? And let me go ahead and kind of show you why. Again, referring back to the last video, I said if you have any 3 basic points that we would refer to kind of as critical points of a exponential function, they should be relatively easy to sketch. So every basic exponential function goes through 0, 1. It goes through whatever 1 in the base is, which in this case is 0.3. And then it's going to go through negative 1 in the reciprocal of the base, which would be about 3 1/3. So the decay function, untransformed, is going to be 1, 2, 3 1/3, somewhere about here. It's going to kind of do something like that. Well, now we're going to look at the equation and say, okay, well, here I have a vertical reflection, and here I'm going to be shifting it 2 spaces up. And so here the horizontal asymptote is now going to be at a, oops, and I'm hitting that at 3, so 1, 2 is about right here. So everything should be below that line. So we're going to be doing our reflection, and then we're going to move everything up 2 spaces, so I wind up kind of back right here, and then down to negative 3 1/3, up 2 spaces to about positive, or about negative 1 1/3, and then we're going to be about here, and you can kind of see the transformed function looking like that. Now, looking at the behavior of the function, we can see that as x goes towards negative infinity, it's very easy to see that yes, y is also going to go towards negative infinity. So at this point, I want you to go ahead and pause the video. If you haven't already worked these other 3 functions out, I want you to go ahead and pause the video and try to identify what is the behavior of the next 3 functions going to be. And you can do it using a graphical approach, the way I do, or you can do a Non-graphical approach, just looking at the characteristics of the function and see if you can determine the behaviors that way. And when you're done, go ahead and hit play and see how your answers look compared to mine. Okay, so hopefully you've worked all the examples out. So part B, hopefully you're going to say, well, that one's going to approach positive infinity based on the fact that we do have a horizontal reflection here, and as we go towards negative infinity, it should behave opposite of what it would do normally. So the basic functions, or the basic points of, E as the base, I would go through 0 and 1. I would go through 1 and the base, which is about 2.7, and then I would go through negative 1 and about 0.4. So we have something that looks like this. 2.7 about here and about here, and these are not the best graphs in the world to work with, but we have that as our untransformed function. And now we see here the negative in front of the x, that is a horizontal reflection, and the negative 3, that's going to be a shift down of 3 spaces. So when I reflect that one horizontally, the critical point that I really care about is on the line of reflection. So this point gets moved over here, and this point gets moved over here. And you can see now, even without doing the negative 3, that as we move our function down, we're going to be about here, here, and here, and you can see that it's going to behave something like this. So as x goes towards negative infinity, you can see that y is going to increase without bound towards positive infinity. So now let's take a look at C. C, hopefully you were able to identify that this one is going to approach a horizontal asymptote, and that has to do with the fact that we really have 2 reflections that we're going to be seeing in this example. So the basic function in this case would be 0, 1, 1, and a 3, and negative 1 and 1/3. So the basic function should be a growth function, 1 and 3, and something like that. Well, now we're going to look at it and say, okay, there is a, pardon me, a vertical reflection, a horizontal shift, and a vertical shift. And let me move those because it's hard to see now. But looking at it here, we know that the horizontal asymptote has been moved down 3 spaces, so ideally everything should kind of be underneath that line. So I'm going to do a horizontal reflection, a vertical reflection, so this one will come down 1, 2, 3, somewhere about here, and then we get that one. Horizontal and vertical reflections done, and then we're going to, or that's the vertical reflection. Now we're going to do the horizontal reflection, so I'm like here, and now you can kind of see that the function should track this way, but the way that I have the points now, I'm above the horizontal asymptote. So we do need to kind of shift everything to the 1 space to the right and 3 spaces down, and when we do, we're going to be right here going underneath the horizontal asymptote. So as I approach positive infinity, I'm going to approach negative 3 on the y-axis. And so the last one here, again, it has 2 reflections, and so hopefully you're going to get negative infinity here. There's the criteria that the beginning of the video gave us visually for my graph. Here I'm going to be at 0, 1, 1 1/3, and negative 1 and positive 3 to show that it would be a decay function initially, but we're going to be reflecting it horizontally and vertically and then shifting everything up 1 space. So there's my horizontal asymptote, and so reflecting it horizontally and vertically, I'm going to horizontally or I'm sorry, vertically here, and then horizontally puts me like this, and then we're gonna kind of shift everything up with that one space, and we're gonna see, nope, I don't want to do that. Then we're gonna kind of see something like that. So as x goes towards infinity, y will go down without bound towards negative infinity. So that's how we can use either the graph of the function or the parts of the function to determine whether or not it was going to be, how the behavior of the function is going to be as we go towards an extreme, positive or negative. Now in the last two here, the graph would be helpful, but so in some cases the graph might be helpful, but in this case, because I'm not going to an extreme, the graph isn't going to be as helpful as it has been in the last examples. So instead, at this point, I'm going to just do direct substitution. As x approaches 2, what is y going to do? So in this case, I just do substitution, and I get 1 over e minus 1, or 1 minus e over 1. And for the other one, again, same thing, just do direct substitution into the function and simplify it, and we would approach 21 over 4. So I'm going to go ahead and pause for now in this video, and we'll pick it up in part 3 after this. Thanks for watching, everybody, and take care.